kind of face forward this way. You don't need to do any computers or anything. We're going to do a bunch of different demonstrations that are, some of them are Halloween related, some of them are just fun. So the first one that we're going to do is I have some zinc here, and I have some ZnCl2. What's that called?
Zinc chloride.
Zinc chloride, and you're going to need the Roman numerals because it's a transition. But we're going to add some zinc chloride here to my zinc, and we're going to begin to heat that up. Now, this won't do anything interesting on its own, but what we are going to do, what's this? It's a penny. What color is a penny? It's copper, right? Copper, bronzy color. Not bronze, yeah, bronzy. And what if I told you that I can change this penny to silver and then change it to gold? You think I'm crazy? Okay, I'll prove it to you. So this is actually going to take a while, and I'm going to put 2 pennies in here. I'm going to change one to silver, one to gold. And that's just going to sit while we do our other demonstrations. So that's going to sit. Okay. By the way, this is called a magnetic stirrer. When we turn this on, it'll stir a solution, so it's not doing anything. It's just stirring, so I don't have to. So the first thing we're going to do is we're going to add some hydrogen peroxide, a little bit stronger than what you can find at the drugstore. And what do you notice about these 3 solutions in these cylinders?
Clear.
They're clear. Okay, I'm going to add my second one. What color is it? It's clear, right? Colorless. What do you think is going to happen when I add my 3rd clear solution? Blue. Why do you say blue? Just feel like saying it? Okay.
Oh.
So what color is that? Yellow.
Oh. Whoa.
Now it's blue.
What just happened?
What just happened? This is called a clock reaction. So in a clock reaction, it will oscillate between different colors. So if we keep watching, it goes back to clear, and then to yellow, and then again to blue. And it will do this for about 5-10 minutes. So the way that this works is we have 3 different chemical reactions going on at the same time. So when they react, you're using up all the other molecules in the solution. So you create another reaction, which then creates another reaction, and it just keeps going back and forth until all the chemicals get used up. So we'll leave this going. Watch that turn pretty colors. Now, if anyone, what happens to people who have diabetes? What do they have to do every day? Sometimes they have to take insulin.
Not blood pressure, but sugar.
Blood sugar, right? So they have to stick themselves. You think that hurts?
Yeah.
Yeah, it really hurts. So I came up with a new way to test diabetics' blood. So we're going to clean our hands, and I'm going to use Windex because I'm a lazy chemist. And this paper right here will help me test my blood. Now, is that actually my blood? No. What just happened? Science, yes, science just happened. But how did that yellow paper turn blood red? What do we think? It's not on the paper, it's actually in the Windex. So Windex contains a thing called ammonia, which is a base. We'll talk about bases later this year. In that paper, when it gets hit with a base, it changes red. Now, we'll leave this up here, and towards the end, check it again, and when it dries, and the ammonia evaporates, it'll turn back to yellow. We have to buy a special type of paper for that. Sorry. I know, you can't do it at home. So, our beaker isn't really doing anything, which is good. It'll do that for the rest of the time. Okay, oscillating reaction. Has it stopped yet? Nope, it's still going. Awesome. Now, you all like fire, right? Because I'm so rich being a teacher, let's burn some money. But first, I'm going to stick it in a solution that'll help it burn better. Don't do this at home. Especially with the $20 bill. I wouldn't recommend it. So, there is an alcohol. Alcohol burns really well, so I'm using an alcohol solution here.
It doesn't even look like it's making the dollar look.
Well, I'm just kind of wiggling it around in here. Got to make sure it's all in the paper. Okay. And let's burn some money. did I burn the money? Exactly, I only burn the alcohol, and this is relatively cool to the touch. So is this just pure alcohol? No, if it was pure alcohol, the money would go up in flames. So what I did was I did a 75% to 30 or 25% mixture of rubbing alcohol to water. And what happened is when you dip the paper in the solution, it absorbs a little bit of the water. The paper absorbs the water. So the water acts as a barrier protecting it from the alcohol. So the alcohol burns off and the water and paper remain intact. So you could try this at home. I wouldn't recommend it with a $20 bill in case you don't soak it properly. So burning money, quick party trick. What's this? A jar. What's that? It's mesh. Yeah, it's a clear lid, right? So we're going to fill up some water. So water's obviously going through it, right? There's holes in the mesh. Correct? What if I told you when I turn this upside down, I can keep all the water in the jar? So that works on that. Okay. Now to help me do this party trick, you need a laminated paper. So we're going to stick the paper on the jar. A little bit will come out. Very carefully removing the paper. Is the water spilling out? How? Why is it staying in there? There's holes in the mesh. How is that staying in there? Pressure has to do with it, yeah. So we just talked about intermolecular attractions, right? Yeah, your test's on it next week. So water has hydrogen bonds, right? Remember, they're not actually bonds, they're forces of attraction. So the water gets in these holes and they become attracted to the other water molecules. And essentially what we create up here is a vacuum. So air is pushing up on top of here, keeping it in. Now, as soon as I break it a little bit, by tilting it, it comes right out. So one of the very, very famous physicists would do this with waitresses' tips. He would do this with a cup at the table and flip it upside down, put it on the table with the tip money inside the jar. So, not very nice guy there. Funny, but I'm sure the waitress didn't appreciate
Must
it.
be a bad person.
Okay, back to this real quick. Let's see what's going on.
Must be a bad person.
Those of you in the front rows, are anything changing to my pennies? Can you see anything?
Now they're different color.
They're different color, right? So, these actually will leave them up here for a little bit longer. Okay, so that's almost done. Meanwhile, we have one more pasta. Pick a color.
Purple.
Yellow, I heard yellow.
Option.
Purple was an option. But okay, in this jar, this is called elephant toothpaste, if anyone knows what that is. So we're going to do, this is hydrogen peroxide. Now this is peroxide that you can't buy at a grocery store. It's 30% hydrogen peroxide as opposed to the 3% that you buy at the grocery store. And all I'm doing is I'm putting some dish soap and some food coloring in it, so I'm not changing it in any way. Stir that up. And then I'm going to add some sodium iodide to it, some NaI.
Oh, hi. Wait, they did that at Big Bang Theory.
Yes, they did do this on Big Bang Theory. Okay, see the steam coming off?
Yeah.
Yeah, don't touch that. Yeah. So, is this actual elephant toothpaste? Can we go scrub some elephant's teeth with this?
Try it.
You try, yeah, it's not going to happen. So the reason why I put dish soap is because hydrogen peroxide is H2O2. So what gases do you think it would go into? There's hydrogen and oxygen. Hydrogen and oxygen, right? So when hydrogen peroxide, like the stuff that you buy at the grocery store, there's a reason there's an expiration date on it. Because it will go into hydrogen and oxygen gas. So don't leave a hydrogen peroxide bottle in like the bottom of your sink for 10 years. They'll probably, you need to open it up after that much time. So the hydrogen and oxygen, it does come out, the hydrogen peroxide will decompose into hydrogen and oxygen gas after so many times. Now, it does take a while. So what we did was we used what is called a catalyst to speed up the reaction. Now, if I didn't add any soap, you would just see a bunch of steam, which that's no fun. We like to see bubbles, right? Bubbles are fun. So if we add the dish soap, then the soap can catch the gas that's being produced, and you get this lovely bubbled reaction. So I'm gonna stick that in the sink. Okay, our penny should be just about done. And these are just 2 vials of water, nothing fancy there. And let's see. Yeah, those look pretty good. So what we're going to do is we're going to take them out carefully because these tongs don't really like this jar. And what color did I change most of it to? Silver. Now, is this actual silver? Did I have any silver in this container? No, it's not silver. What is it? It's not, well, silver's not copper. Silver color. What else did I tell you I added to this beaker? Zinc. It's zinc. Now, to change it gold, you heat it up. Yeah, I know, it's like I'm making pancakes. I'm flipping the penny over so it doesn't burn. Now, for this, you have to use a certain age of penny. You can't use ones that are really recent. Does anyone know why? Yeah, Jenna hit it right on the head. There's not enough copper. So since 1982, pennies were made with mostly zinc, not copper. So you gotta use a penny that's older than, or 1982 or older. So you can kind of tell. Looks kind of goldish, right? I mean, it's not perfect. I mean, it wasn't very clean to begin with. I cleaned it, but they're old pennies. What can you do? Does anyone know what this actually is? Is it gold? It's not. I didn't make gold. What is this? What did I put on here? Anyone know? Okay, guess. Okay, so we got zinc, and then I heated it up. So I'm not melting the zinc off. I'm not doing anything to the copper. I'm making an alloy. What's an alloy? A mixture of metals. So what happened was the zinc heated up and the copper blended with the zinc, creating brass. So I created a brass penny and a zinc coated penny. Now, next class, not this class, we're doing some board races, and the top 2 people get the pennies. So there's some more motivation there to kind of make sure you understand what you're doing for next class. Any questions? Because that's all I got for you. Okay. We're good, Miss Mercer.